face. Okay, okay, sharing your face. Let me say again. Okay, let me say again to you. The invitations has been sent to your email. Okay. If you join through a WhatsApp mail or just I need to verify your attendance. That attendance not goes through to me. Okay. You understand what I mean?
Yes, sir.
Yes, sir.
Okay. Because if you didn't get invitations through your email, tell me. Okay. In every class, go to your email again and then click from your email. Then the attendance will come automatically to my system. Okay. But if you joining the class through WhatsApp link, and then you need me to admit your entrance to the class, it means that your attendance is not recorded in the Google form. Okay, can you understand that?
Yes.
Okay, good. Huh? Okay, so let me say this to you that okay, so let me increase the layout. Okay, okay, we'll go slow, very slow. Okay, we'll go very slow today. Semua dah makan Semua dah makan. Okay, very good. So Darwish dah makan omelette Tasnin Asfara. Tashin Asfara. Tashin Asfara. Afsara, sorry. Tashin Asfara. Hello. Wali Zargar. Hello, Wali Zargar.
Yes, sir.
Where are you now?
I am in actually. Yes, sir. What you asked?
Where are you now?
I am in India actually.
In Kashmir, right?
Kashmir. Yes, Kashmir, India.
Okay, all right. So I'm pretty sure you are done with 3D. 3D, we call it 3D resultant. 3D resultant. Okay, 3D resultant. I'm very sure. Okay, very sure. Then 3D resultant. Okay. We will do 3D equilibrium today. As I mentioned in the last class, okay. You have three methods. Okay. What are the methods? Tell me again. What are the methods? Tell me again. First one is what?
First angle.
Then followed by?
Second angle.
Then the last one?
Coordinate method.
Great. Okay. So you should understand that. But there will be always tricks. Tricks. The question of test one has been set. Okay, it's much more simpler. It's much more simpler than the example that we have done. But they will always trick to check your understanding. To check your understanding of the 3D. To check your understanding of 3D.
Sir,
Yes.
may I know
Yes.
when is test one?
Okay, it has been published in your system, right? I will check. Okay, so you can check your timetable for the entire semester. Test 1, test 2, test 3 for most of the subjects. Okay, for most of the subject. Okay. So so do you have three methods? Okay. It always combine. It always combines those three methods. Okay. Are you then okay? Are you then? We move on. We move on today to the 3D. To do 3D. Okay, 3D in we call it as equilibrium. The simplest one. Then after this week, we will come back to 2D to do the moment. Okay. So can everybody smile to me? Can everybody switch on the camera? Can everybody switch on the mic and say, hey, say like that. What? I give you a few minutes, okay? Okay, switch on your mic. Switch on your mic. Switch on your mic. Hello? Okay, say, hey.
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 Right, at least, okay, someone happy with me today. I try to make you happy, okay? Right, so I will go very, very slow. Okay, I will go very, very slow. I'm no, okay, let me discuss in university, okay? We give you understanding. We provide you with the list of question for every chapters. And we're not going to check you have done all those or not. Okay, it's on you. Okay, if you try to answer that, compare the answer with your friends. If you didn't get good, if you didn't get the same answer with your friend, okay, they must be somewhere in your calculation. In your calculation. Then what to do is actually you should try to find where is your errors and so on. Okay. Right. So you may send to me the solution, but it takes some time for me to read your solution. Okay. All right. So let's begin with 3D today. Equilibrium. We are on the tracks. All right. We entire screen there. Go to here. Haris Daniel, how are you doing, Haris Daniel?
Yes, I am doing good, sir.
So where are you now?
I'm at home. Keluar.
Keluang. Okay, Balkis in Kelantan. Lim, where are you, Lim? 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 Lim Fang Juan, where are you?
Yes, sir. I'm at home.
Home, where? Kat mana rumah?
Johor.
Johor kat mana?
Ulu Tiram.
Good, Alright, so what to do now is we will go to recording, okay. Alright, so what to do now is I should go to the, okay. This is simplest one, okay. And don't worry, I will finish before 10. So I will finish before 10 because you have another arrangement at 10, right? So, Famid, can you smile a little bit, Famid? Why? You cannot smile?
Sir, I just woke up.
Okay, just woke up. Right, so click here. Click here. Okay. Okay, so let add new slide there, new slide here, new slide here, new slide here. Okay, so and a file save as desktop SKMM1203 week. This is week 4 already, lecture 2. Okay, lecture 2. Okay, desktop. Okay, so be patient. Okay, be patient. That you will come. You will come to UTM. Next semester. Okay, please come and say hello to me. Even I'm not teaching in the second sem. Okay, so as I mentioned to you, you do static with me. Then in your 4th year, you will do aerodynamics under me. Okay, right. So we do right. So let begins. Okay, today material. Right. This. Can you see my slide?
Yes.
So 3D. Okay, we do 3D. Today is equilibrium. So equilibrium. 3D equilibrium. Okay. So it's so easy. Summation of force in X, or you call it Rx. Result that everything goes to 0. Simple as that. Summation of force in Y, or you call it some books to Y, everything goes to 0. Summation of force in Z is equal to Rz, everything goes to 0. Okay, everything goes to 0. So easy. So easy. So you sum all the force channel in I, in J, and in Z, and equate it with 0. Then you have to do some calculation. Okay, some calculation on these on the calculation. Okay, only the calculation. Okay. So what to do now? We move on. Okay, we move on as usual. Okay, so 3D resultant. Okay, 3D equilibrium. So it's telling you a little bit. Okay, telling you a little bit. Okay, so summation of force in X. Can you see my PowerPoint there? Can you see my PDF file on 3D dimension analysis?
Yes.
Very clear?
Yes.
Hello?
Yes, very clear, sir.
Very good. So I just want to see, I want to have your voice. Nak dengar suara you. Sayang saya ni dengan student Aero ni. So force in X is equal to 0, force in Y equal to 0, force in Z is equal to 0. To is example here, determine a force 3 if the shown in the equilibrium. So F3 theta XZ, F1, F2, this is this. You resolve it into I, into J, into Z is equal to 0 and F1, and then F2, and then equate everything equal to 0. There's a finish. F3 is equal to F3 equal to this. Right, so that equal to F3. Right, finish the class today. Understand or not?
No, sir.
No, sir.
No, sir.
Okay. So who can understand my brief just now? Nobody. Okay, it's nobody. It's okay. Right. So we should close it if you don't understand. Do you want to save it? No. Okay. So then let begin with some example. It's go direct to the example. We go direct to example. Okay. So we go to okay. Can you look at notes that given to you on a resultant also. On the resultant. Okay. I'm very sure you have tried all of them. Very sure you have tried all them on equilibrium there. We did 3. Okay, we did 3. We did 3 example. Okay, as I said, every chapter I can 3 or 4. The rest is on your effort. On your effort. Okay, that is the on this. Now it goes to the equilibrium. Okay, equilibrium. Okay, so this is something like this. This is something like this. Okay, this is something like this. Okay, so the mass is maintained in equilibrium. With the support of AB. AB is supported by AC and AD. Okay. AD, okay. AD. All right. AD. So, okay. Determine the tension in cable AB and AC. And the mass M. Something like this. Okay. And at 30 Newton downstairs. Okay. So, this is also like this. Okay. Also like this. Okay. We try to do, oh, this is a simple one. Okay. This is a simple one. Okay. For aero student. Okay. This is a good one for us to do the calculation. Okay. Okay. This is the best one to do. This means F1, F2, and F3. F1, okay. F2, and F3. If the system is in equilibrium. Okay, is in equilibrium. Okay, F3. Okay, there. All right, we try to do that. Okay, are you ready to do? Hello. Are you ready? All right, very good. Okay, I know that you always wish me. Right, this is the simplest one to understand. Remember me. Okay, remember we're going to say that your exam is much more simpler. Okay, than the exam. Than the example, but there will always a tricks. There will always tricks to check your understanding. There will a trick to check your understanding. Okay, so okay, I am very sure aero student no problem with that. Okay, I'm very sure no aero student no problem with that. Okay, let begin. Okay, file edit. Take a snapshot here and then example here. We call it as example 1. Okay, so copy it down. Okay, copy. Okay, so all right. The question says like this. The question says like this. It says that. Okay, it says that the system in equilibrium. Okay, the system in equilibrium. Sometimes we didn't see. In 2D particularly, we didn't say the system is in equilibrium or not. You have to understand words by words. You have to read it. We read all the question first. What to do now? To do now to read all the question first. Okay. Determine the all forces. Okay, right. So now I have to do okay. So edit, okay, edit, take a snapshot of it. So from there to there. Then take a copy here, move to here. Okay. Okay, so nothing easy. It's not nothing difficult. Nothing difficult. Okay, so just resolve all the forces and equate it to 0. So how many forces are there? Forces. Okay, forces F1, F2. How many forces are there? F3. And 100 Newton there. Okay, and then you what to do now? Tap here, tap here. Oh yes, I have plans. Who among here who's staying near to Johor Bahru or Skudai? Who's staying near to JB, to UTM? Can put your name in chat. Put your name in chat. Those are staying near to UTM. So most probably I will take you to for a lunch somewhere. Okay. Okay. So F1. That everything goes to 0. Rx equal to 0. Ry equal to 0. Rz equal to 0. I, J, and K. Look at force 1. Force 1, if you are given distances like this is dx is 2 meters, dy is 3 meters, and dz is 4 meters. Okay, so resolve it into F1. So F1, okay, dx is 2 over something. Tell me. F1, okay, dy is 3 over something distant. Okay, F1, okay, dz is -4. Tell me what is the distances. Okay, d. What is d? D is equal to set 2 squared plus 3 squared plus 94 squared. Okay, tell me what is D?
5.39.
5.39. Very, very clever student. 5.39. 5.39. 5.39. 5.39. Okay, F2. So you are given force 2. You are given here you are given here. Okay, you are given here force 2. Okay, theta 2y is equal to 30 degrees. Theta 2x that equal everything to 110 degrees. Okay, get to me theta 2z. Okay, get to me now. You know that cos squared theta x is given plus cos squared theta y plus cos squared theta z that equal to 1. So tell me what is theta 2z then. Tell me now. Do your calculation. Tell me what is your theta 2z. Tell me what is theta 2z. So, how many hours want to do that? Hello? Talking alone. What is theta 2z? It should be more than 180 degrees. Should be more than 180 degrees. It may not, because theta x is 110. Hello? Hello? Balkis said that 111.39.
Same, sir.
And anybody can confirm her?
Betul, sir. Betul.
Okay, very clever. 111.39. 111.39. Theta 2z is 111.39 degrees. Okay. So you are having F2 and then so F2 cos theta x is given by 110 degrees. F2 F2 cos theta y is given by 30 degrees, and F2 theta z is equal to 111.39. Blame Balkis if the thing is not right. Okay, so 0 in x, 0 in y. Okay, so in z you're having what here? You're having this is equal to negative 100. Okay. So force 3 you are if this is 30 degrees, okay, so you will have here from there to there is 60 degrees. Okay. FV, okay, you are having now FV is F3. F3 cos okay, F3 cos 60 degrees. Okay, this is 60 degrees. In Fy is F3 cos 60 degrees. So once you have this one F3, so you will have that one is a component of what? F3 sine 60 degrees. F3 cos 30 degrees, same thing. F3 cos 30 degrees. Then that one is 40. Then you resolve it into the INJ. So that one here, Fz. Okay, Fz. And that one here, Fx. Fx. What is Fx? Fx is negative. Okay, negative F3. Okay, what is Fz here? Fz is F3 cos 30. F3 cos 30 degrees. Okay, multiply by cos 40. Cos 40 degrees. Okay, is equal to F3. Okay, F3 cos 30 degrees sine 40 degrees. That everything goes to 0. Okay, everything goes to 0. All right. Everything goes to 0, and then that's it. Okay, can you now summarize it? That is equal to 0. So become equation 1, then equation 2, equation 3. Write in chat. So summarize the F1 2 over 5.39, F2 cos 110, F3 cos 30 degrees sine 40, and so on, equal to 0, equation 1. Tell me, write in the chat equation 1, equation 2, and equation 3. Do that now. Write in the chat. Hello, write in the chat. What is equation 1? Write in chat what is equation 2. Hello, how long you want to do that? Hello, can you write those in the equation 1? F1, so multiply by 2 over this, F2 this, okay, that everything goes to 0. Everything must go to 0, okay, everything must goes to 0 because it is in what? In equilibrium. So equation 1 finally is equal to 0. Equation 2 equal to 0 at the end. Equation 3 also equal to 0. I want you, okay, to do that. No, it's not 8 here, it's 0. Erase, small erase here. Lim. 0. Is it Lim? Is it 0.37 is F1? Equation 1?
Yes, sir.
Equation 2 is not right because you have to add on the 100 Newton. Is it 0.37 F1?
Yes, sir.
Okay, I want to write it here. Can you tell me slowly? Okay, what is it? Tell me again, Lin. Okay, right. Tell me. Lim,
Sorry, sir.
tell me the first equation slowly because I want to write here.
0.37
F1 plus what else?
plus plus 0.56 F1.
F2.
If
Okay.
F2 is negative 0.34.
We want to do F2 because everything is minus what?
0.34.
3.34 F2. Then
Minus
else?
0.56 F3.
F3, everything goes to 0, right? That is first equation. Am I right?
Yes, sir.
And then second equation, tell me.
0.56
0.56
F1
F1 followed by, okay, and
plus 0.87 F2
2, then
plus
Plus?
0.5 0.5
F3
minus 100.
minus 100, right? Okay, equal to 0. Then the last one,
Negative 0.74
F1, Then followed by
minus 0.36.
then followed by
Plus 0.66.
everything goes to 0. Okay, are you getting the same answer with him? Everybody, tell me. Are you getting same
Yes, sir.
answer with Lim? Very good.
Sama.
Okay. Sama, very good, very good. Now, no more statics, no more statics. Okay, it's a mathematics for you. Okay. You have, unfortunately for this example, you have three. How many unknown there? How many unknown?
3.
Unknown. 3. F1,
3, sir.
F2. So then you have how many equation there?
3 also.
You have 3 equations. 3 also. Okay. I give you 10 minutes to revise your mathematics to get F1, F2, and F3. There are functions. There are functions in your calculator. I think you learn it in your matriculation, how to solve 3 equation and 3 unknown. Do that. Okay. This is no more statics. This is your mathematics. Okay. Do that. Do that. Tell me F1, F2, and F3. Do that. Okay.
Sir,
Yes.
masuk calculator terus sir? Ke kena buat jalan kira kak?
Kena ada jalan kira lah. Tunjuk sikit.
Okay.
Okay. That one is your mathematics. So, okay, everybody get A1 in what? A1 in this is, I like this one. I like this question. PD. Okay, I like this question also. You want to complete that at home or you want to do that now? Better you do that now. Better you do that now. Better you do that now. All right, I want to see who is the fastest to do this calculation in mathematics. Tell me, what is F1, F2, and F3? I'm not going to repeat it again. F1, F2, and F3, because I want to go ahead with more example here. OA table. There are how many cables there? Okay. OA here. This is okay. AD. All right. Okay, I like that one. Okay, I like also that one. Okay, I like also this one. I like also this one. Okay. I like also this one. F3. Okay. There is a calculation on how to do that and to solve this equation.
Sir,
Yeah.
may I know just now sir mentioned that our test one is uploaded on the system. What system is that?
What is it?
The date for test one.
Test one is
What
I will
is the
check with the
system?
how to do exam is online.
No. I mean how to check the date.
To check the date. Okay, I have a system. My system is that I'm not sure I can check it or not. Okay. Okay, I will see I will see the link for student, okay?
Okay, sir. Thank you.
Okay. So anybody can share the answer in chat? Hello? Can someone share the answer in chat?
Sir,
Question? Yes.
F1 I got 100,
That's 100.
150, 152.
Right. Everybody get the same answer with him. Okay, 152 Newton. F2.
Negative 60.
F2
Point 94.
what? Not 5.9. F3.
137.7.
Everybody get same answer?
Yes, sir. Almost same.
Okay, if it is almost the same, okay, those who don't understand how to do that calculation, please revise it again at home, okay? Because I'm very sure there is a solution on how to solve it, okay? Right, so we move on, okay? We move on to another example here. So let me go here, insert here, go to new slide here, new slide there, new slide there. Okay, new slide here. Okay, new slide here. All right. So I'm interested with this example. Okay, I'm interested with this example. Okay, we move on to this example. Okay, so we copy it. Okay, edit, take a snapshot of it. Okay, copy. It says, so we call it, this is the first one just now is example one. Okay, today this is example. Draw this, that, here. Example one. Okay. Move here. We call it as example two. Example two. Okay. Example two here. Then all right, it says to you that a figure shows 100 kilogram mass, okay, is sit. Look at very clearly, look at very detailed the position of the forces, okay, supported by three cables. What are the cables? AD, okay, okay, AC is here, and AB here to determine the in the equilibrium. Point O, okay, point A is sit below point O. See, okay, it sit below point O. Then what to do now is we go here. Right, we to do here, edit, okay, take snapshot of it. We move to there. No, we cannot do that because that not right. No. Edit, take snapshot of it. Copy here, move here, move this here, move here, move there, move there, move here. Okay, move there. All right. Right. So nothing to worry. Nothing to worry. How many forces are there?
3.
4, including the
Four, sir.
4 forces. Okay, forces. Forces. Okay. Forces is P, A, D, T, A, B, T, A, C, and we call it MG. If you want. Okay. Split it into a table. Split into a table, okay? Into I, into J, and into K. I into J into K. Let me scale it down a little bit here because I want to do the calculation soon here. Okay, so as usual, Rx equal to 0, Ry that everything goes to 0, Rz equal to 0, 1 by 1. Okay, Mg is always in Z, negative Mg there. negative mg, 0 here, 0 here. TAD is only negative TAD. Okay, TAD, because cables, when you cut the cable here, okay, tension is out of the point. So this is your boundary here. So your boundary, okay, you have how many forces there? So you have here TAD, always out of the boundary. Same principle as what we did in the 2D. TAD. Then you have TAB, out of the boundary. TAB, TAB there, and then you have a TAC there. TAC, TAC there. Okay, then if you want to extend the drawing it until TAB, okay, no problem there. TAC. So what to do now is erase. Here is erase here, and then a small medium erase here. That TAD. TAD. We do one by one. So 0 in this direction, 0 in this direction. TAB, if here is 60 degrees, here is 90 degrees. It is just x on plane, is x on plane YZ. See, it just plane YZ. So no force in x for AB. No force in x. So simple as x. No force in x. Okay, no force in x. Okay, TAD. If you know here 60 degrees, you should know here it should be here is 90, here is 150, here is 30 degrees. Okay, right. So here is 30 degrees. Tiga puluh degrees. So you will have how many forces there? How many? Okay, so that is a component of TAD in x. Okay, TAB in x, and this is TAB in z. Okay. TAB in Z. That's it. Okay. So what is a TAB in X? This TAB in X is simple as TAB. Okay. In Y is a TAB cos 30 degrees. And then in Z is negative TAB sin 30 degrees. Are you agree with me?
Yes, sir.
Everybody agree with me? Good. Okay. All right. Now I want to erase all the. Okay, it's always like this. Okay, TAD is simple, TAB is simple, MG is simple, but TAC a little bit tricky because it involved in the second angle method. Are you ready? So I want to erase the other components. Just to concentrate on TAC. Are you okay with that?
Yes, sir.
Yes,
Are you ready? Everybody ready?
Ready, sir.
Okay, pandai. Pandai. All right, I will erase the other component, okay, to make sure you are well understand but the TAC, right? So TAC, you have one force only, TAC there, right? So erase it for you. Okay, TAC there. So now what force you have here? TAC. TAC, bank's TAC code. TAC. Is act from here to there. TAC. Then as simple as a resolve it into Y. Resolve it into Y. Okay, resolve it into Y. This is what? FV. Okay, FV equal to FY. So FV. Okay, this is and then FV. So no, I will erase it a little bit. FV, that everything goes to TAC cos 40, cos 40, that equal to FY. So you have a TAC, okay, TAC, okay, TAC cos 40 degrees. And that if that component is TA is 40 degrees, you should know this is TAC sine 40. Right? This is a component of T. This one is that component there, okay? That component there is TAC sine 40 degrees. Okay, TAC sine 40 degrees. Sine 40 degrees. So nothing else, just resolve it again into these what you call it as X and Z. Okay, this is TAC TAC in X, TAC in X, and this is TAC in Z. What is TAC in X is it is TAC sine 40 degrees. Okay, TAC sine 40 degrees. Okay, TAC sine 40 degrees multiplied by cos 30. Cos 30 degrees. Okay, cos 30 degrees. Then okay, on this part we will have TAC sine 40 multiplied by sine 30 degrees. Okay, that's it. So you have three equations there. Three equations, right? So the first one you have negative TAD, okay, plus TAC multiplied by sine 40 degrees. You resolve it, okay, cos 30 degrees, that plus 0 is equal to 0, nothing else on that equation. So but you don't read the question. It's given to you already. Okay, 10 kilogram. 10 kilogram. 10 kilogram. Okay, it is a 10 kilogram. Okay, 10. The second equation is TAB cos 30 degrees plus TAC cos 40 degrees, okay, minus 10 times 9.81. Okay, so you have how many unknown are there? Three only. So TAC, you resolve TAC and TAB and TAC first. Okay, so you resolve, okay, pandailah you, negative TAB sine 40 degrees, TAC sine 40 degrees, okay, negative TAB sine 40 degrees plus TAC sine 40 degrees, sine 30 degrees, that equal to 0. That is equation, we call it equation 1. Okay, that is, we call it that here, close here. That is, we call it equation 1. That is equation 2. Then there is equation 3. So this is TAB here, TAB here, TAC here, TAC here. Resolve equation 2 and 3 first. Get the TAB is what? You TAC is what? And then TAB, TAC, and TAD is what? I give you about around 10 minutes to do that. Okay, do that in 10 minutes. Do that in 10 minutes. In 10 minutes, okay? All right. Don't put yourself in pressure, okay? Do that, okay? All right, so this is your calculation there. The rest are same principle with these, same principle with the, that also, that one also, okay. I like that one. Okay, at this stage, I cannot guide you. Okay, you have to revise your calculation. Just resolve equation 2 and 3 first. You will get TAB and TAC. And from TAC is simple as you can get TAD. All right.
Sir,
Yeah.
yang soalan tadi tu dapat tapi nilai dia macam besar.
How can?
Saya dapat 400 something.
What is the mass given? 10 kilo, 10 by, it's possible. Huh? It's kg. So what is your TAB then? Tell me.
TAB 498.28.
Wait, 498. TAB, 400?
98.
What?
0.28.
2 Newton. TAD?
TAD 432.88.
Hello?
CAC 778.
7.
778.57.
Okay, we wait until the other friends to confirm your calculation, okay? So that you getting the same one? Everybody getting the same answer for which him? You getting same answer with him? Hello, everybody?
Different, sir.
Different, okay. What is your answer, Lim? Lim?
I type in the
talking to
chat,
me?
sir.
You have in chat. So TAD 41, TAB 47, TAC 41, 47. Okay, it's like you are wrong. Okay, who told me this answer?
Ni sir, Aizat.
Exact. So it means wrong. Okay, because by majority, you are nobody has agreed with you. Okay,
Okay sir.
so everybody decided to go for smaller amount of value. Okay, smaller amount of value. Okay, so you will have here TAB there, TAB is 42.21, 47.21, 47.21 Newton. TAD. Mana TAD? Where is TAD? TAD is 41.31. 41.31 Newton. And while TAC is 73.76. 73.76 Newton. 73.76 Newton. Okay. Right. Everybody get the same answer. I give
Yes,
you
sir.
until good. I give you until 9:37 to tidy up your calculation there. Okay, we move on. All right. Okay. If no issues, we move for the last example of the day. I like this one. I like this question. All right. So I like this question. I said it again. I like this question. All right. So OA is given by that. So you have 3 cables. 1, 2, 3, 4, 5 cables there. So the system in equilibrium, okay, determine the forces in all cable. So we move on, edit, take a snapshot of it. Copy, move it to here. Paste. It says that, okay, it says to you that, okay, a system is in equilibrium. The 100 kilogram loaded is suspended at point E, it pinned at point E, there where the point E is sit on plane ZY only, ZY only, ZY only, okay, ZY only, okay. Then it is connected to point A. Point A, you have how many cable there? 1, 2, 3 cable there. So any idea how to do this? A is equal to any ideas how to do this? On X, AC, BK, okay, OC is equal to 0.9, OD is equal to 0.3. Right, so what to do now is you have two points to do the analysis there. Okay, 2 points to do the analysis. Okay, 2 points to do the analysis. Edit, copy here. Okay, move on to, okay, to here, please. Okay, you have 2 points here, 2 points of analysis. Okay, so let I enlarge it. Okay, enlarge it. All right, enlarge it. Okay, enlarge it. Okay, so you have 2 points here. Right? So the first thing is you cut the cable at this point. So you have to do the analysis at point E first. Okay, point E. Okay, that is point E. As simple as that. You will have a cable there of FEF, and EA. FEA. Okay, so by drawing, okay, so this is Z, this is Z axis, so this is, say that Z axis going that way, so then Y axis going up, this is Y axis, right, Y axis, so you have a cable here, okay. The weight is given to you by given by 100 kilogram there. 100 kilogram. Okay. 100 times G. 100 times G. Then you will have your T, TEF, and also TEA. All right, so you have to do the analysis at this point first. Okay, so the first one here is 50 degrees. 50 degrees. And there is, that one is 60, there is 30 degrees. Okay, there is 30 degrees. So there is 60 degrees. So do your calculation. Okay, forces, okay, forces, right? So you have TEF, TEA, and mg. So that one you resolve it into also, if you want to I, J, and K is same thing. I, J, and K is the same thing. Okay. It's actually 2D analysis on plane Z, Y. So no other forces in X, 0, 0, 0. Okay. In Y, okay, in Y you have, okay, you have here negative in Y here for a negative mg. Negative mg, negative 100g, okay, negative 100g. Then what to do now is to change the color here. All right, so TEF in Z is TE, okay, TEZ, okay. So it is a TEF multiplied by in Z TEZ cos TEZ, okay, TEZ positive cos 50 degrees, okay. And then in K you have in Y is TEZ, okay, TEZ, okay, TEZ by sine 50 degrees, all are okay. That one should be positive, okay, that one should be positive, that one should be also positive. Okay, TEA is a negative TEA, negative TEA what here? Negative TEA, cos 30 degrees. Then here is TEA sine 30 degrees. Okay, this is 1, 0 here. Everything goes to 0. Okay, Rx is 0. Summation Ry is equal to 0. Summation of Rz equal to 0. Can you do me to get TEF what and TEF here, EF, okay, EA, and TEF and TEA in Newton. Get to me. Do that calculation. Okay, do that calculation. EF in Z.
Sir,
Yes.
may I ask why TF for J is cos how much? Cos 60.
This is sine 50, right? Am I right?
Not just because science 30, it also positive.
Should be sine 40. Sine 50.
Sine 50, yes, sine 50. Sine
And then for the K is
cos.
cos 50.
cos 50. And then here, EA in Z. That one correct, right?
Cos 60 and sin 30.
Now here is 30. Here is 60. Here is 60. Here is 30 degrees. Here is 30 degrees. Okay. In Z is should be cos. Yes, cos 30. Cos 30, and this is sin 30.
Negative cos.
Negative. EA. You mean? Which
Yeah,
one negative? You said
for K.
for K. For K, a negative TEA. Here is 30 degrees. You agree with me?
Yes.
So in Z is negative TEA. Z is positive. Okay, Z is positive. Z is positive. Y is also positive.
So YZ is positive.
Okay. So that one clear. Okay. So if you are not clear here, this is that direction. That is goes to direction. So in Z should be negative. Okay, negative, sure. So it's negative here. Okay, Z is negative, and in Y should be positive.
Positive.
All right. Okay. Are you clear? Are you agree with me? The rest? Okay. So
Yes, sir.
good. Again, get the TEF and TED for me. TEA. Okay. Get the TEF and TEA for me. Are you put in the chat? Can write in the chat if possible. Okay, so the distance OA from O to A is 1.2, and then BK is B to K, B to K, B to K, B to K. Here also 1.2, B to K, B to K. B to K is 0.8. OC in 0.9. OD is 0.3. Can you put answer in the chat? Can you put answer in chat, please? What is TEF and what is TEA? Hello, it is a simple. Just I made a mistake somewhere here. All right, so it has been J is positive there. Z is negative. Okay, right. So here is for EF. Okay, EF. EF. Both are positive. Okay, so tell me what is the answer for that? Hello, can you solve this equation as soon as possible? Get to
Yes,
me.
sir.
Yes. What is the answer for that?
For TEF, I get 87.94.
87.94 Newton. And TED?
Yes.
TEA.
TEA, I got 65.27.
65.27. Assuming you are make a good calculation, okay? Then what to do now? You move on to point A. Okay, you have to resolve a solution at point E, and then we move to point A. Okay, then point A. So analysis. At point A. So point A, there. So how many forces at point A? T, okay, T, A, K, T, A, K, T, A, E, that you know already. Okay, T, E, A, T, A, D, and T, A, C. Right? 1, 2, 3, 4. Then you resolve it as usual into I, J, into I and J and K. Okay, we move on to one by one. So we look at here the distance all are given. So when we do analysis at point A, that one, remove that one. Okay. Remove that one. Okay, remove that one. Now is we do the analysis at which point? Analysis at point A. Then you have a what? You have the calculation of here. T that one, okay, that one, okay. So TAD, so TAD here one first. TAD here is TOC, TAK, and TAE. Right, 4 forces. Okay, TAE, you know the TAE. Okay, TAE is in the so here is if here is 60 degrees, here is 30 degrees. All right, is 30 degrees here, 30 degrees here, 30 degrees here. You know TE is no forces. It just acts on the y and z axis. Okay, so no forces in x. TEA, no forces in x. You have a 65.25, 65 EA, 65.25, 65.25. Okay, that one is in J. In J is in J. Okay, J is negative. All right, so it is in J. It is negative. Okay, in J it should be negative. Okay. In J, it should be negative. Negative. Be careful. Okay, be careful. Negative, because it goes to this is the vector. So you have a force in that direction. Okay, you have force in that direction. This is T. Okay, in Z should be positive, and in Y should be negative. All right. So in Z is a cos. Okay, cos 30 degrees. In Z it should be cos 30 degrees. Cos. Here, cos 30 degrees, okay, and here is negative sine 30 degrees. Are you agree with me? Hello? Any? Yeah.
I got different answer for TEF and TEA.
What is your answer?
2.48 and negative 1.84.
Can someone it shouldn't get negative. Impossible to get negative. Impossible to get negative. Okay, impossible to get negative. Okay, can someone check the answer, Ken, please, again? Because it attached to 100 kilogram. Very heavy.
Oh, okay, sir. I know. Okay, I used the wrong math.
Okay, it's okay. Small matter for you. Are you agree with me? TAA like this? Before we go ahead?
Yes, sir. Yes, sir.
That one right? Okay. Okay. So T in Z should be positive and K should be negative. I know this is a complicated question. So we move on the TAK, T from A to K. A to K. A to K is you are given here. You can use a dx over dy. It's easy for you. So A to K, from A to K. No force in what direction? Tell me. A to K. AK. No force in what direction? Tell me again. Hello.
No force in Z direction.
Ay, fun sayang. A to K.
X, sir.
X. No force in X. No force in X. Okay. So then you write the TAK. TAK. Okay. I know this is not easy. Please revise it at home. Okay. What is the distance in X? 0. Okay. The distance in X is 0. A. From A to K. In Y, A to K in Y is negative 1.2. Negative 1.2. A to K in Z is also negative 0.8. Okay, get me the distance there. Get me the distance there. All right, so from TAD, now we move into TAD. Tell me, from A to D, no force in what direction? From A to D is no force in what direction? Hello?
K.
A to D, tell me what no force in what direction?
K.
Pandai. So you only have here TAD. Okay, from A to D, AD. A to D is given by 1.2. Be careful at the positive and negative. TAD in X is negative 0.3. See, negative 0.3, negative 0.3. So get to me that distance. What? So TAC, no force in what? Tell me. TAC no force in what again? Hello. TAC no force in what? Hello.
Z.
TAC also no force in Z. So you have here TAC, the distances here. TAC distances here. Okay, T from A to C, okay, A to C in X is positive 0.9, okay, positive 0.9. A to C in Y is 1.2, okay, A to C is given by 1.2, okay, get to me all those distance. What is the distance, from A to C, okay, A to D and A to K. Get to me. All those are equal to 0. All those equal to Rx equal to 0. y that equal to 0. From here, z equal to 0. From here, you can straight away to get TAK. TAK. From there, you straight away get TAK. From TAK, you will have a TAC, you will have a TAD. Be careful with distances here. I sometimes can make mistake. I'm teaching this subject for 20 years. Sometimes I can overlook the positive and negative like this. And so look at very carefully. You do the analysis point A. From A to point D, the distance are positive or negative. A to D, or A to C, the distance are positive or not. Be careful from A to K. A to K. A to K. From A to K. A to K in Y is negative. It goes down. A to K in Z also positive because it went down. Then you got the distance, all the distance. You will get the other forces. So you will get TAC, okay, is what? TAD is what? And you will get TAK is what? Okay. So can someone tell me the distance from A to C? 1/2 and 1.2 and 0.8 is what? Tell me. Hello. Hello. Hello, TAC, distance AC.
1.5 sir.
1.5, okay, do that calculation, 1.5 over 1.5. Okay, TAD, distance from A to D.
Is A to D.
Okay, from A to D, 1.2 in X and negative 0.3 in Z. What is the distance there?
Answer 1.2 and 1.3 terbalik. And 0.3. X should be 0.3, negative 0.3, and then Y should be 1.2 for TAD.
TAD. So we okay, TAK, you agree with me? This one TAD. We do it again from A to D. Okay, A to D. DX is negative 0.3. Correct. Okay, small erase, negative 1.3. Negative 1.3. Okay. Negative 1.3 there.
On 0.3.
Negative, right? Negative 0.3.
Yeah.
Okay, here is here is 1.2.
So the hypotenuse is 1.24.
These okay, 1.24.
Yeah, I don't know if it's correct or not.
24. Okay, TAC, we do it again from A to C, X is 0.9. Y is of course 1.2. What is the hypotenuse of the distance? AC 0.1 and 0.9 and 1.2.
1.5 sir.
1.5. Are you confident?
Yes.
Okay. Nothing different. Can you tell me what is TAK? TAC and TAD. Okay, nothing confusing you. Okay, just no. Maybe it's like the. Okay, tell me TAK is what, TAC is what. TAK is simple from Z channel. TAC is what? TAD. Then we will finish the class. So someone share in the chat. Share in chat. TAK is what? I put it there. I put it there. I remove it there. I don't want to make you confused from your calculation there. So you will have the rest that you should do. The rest you should do is that one. Okay. TED. TETAK is what? Tell me. Okay. TAD is what? Tell me. DAC. Then we have finished the class today. Tell me. All are in Newton. Hello, hello. Hello. Tell me T. Tell me TAD, TAC, TAK. That's it. Then we finish the class. We're still working on that. Okay. Anybody want to share me TAD, TAC, and TAK, please? Hello? Are you with me?
Yes sir. Tengah kira.
Yeah. That's part in examination. You are limited time. You have limited time. Anybody want to tell me? All right, I'm coming back. I'm going to toilet. I'm coming back in 3 minutes, okay? Okay, anybody want to tell me TAC? Please, okay, hello. Lim, TAK is 105. Everybody get the same answer with him.
Lebih kurang ke?
Okay. Alright. Tell me, I want to write. Okay. Tell me, TAD of what? Tell me again.
TAK 105.95
TAK 105 Newton. Okay. Then TAD.
TAD 90.98.
TAD 90.98 Newton.
90.98.
99.
90 je. 90.98.
98. Okay. TAC.
TAC 36.68. 36.68.
Right. So that is a possible answer for that calculation. Then please revise it at home. Okay, please revise it at home. Okay, please revise it at home. Make sure you understand 3D. Okay, I will do another 3D, 1 hour 3D next week. Then before we go to moment, this is another important characteristic in the engineering subjects. All right, so I'm sorry again for taking your time today. Okay, so that's end of our meeting today. So I'm sorry if I look very carefully on positive or negative. Even me also can make mistake. So at this age, looking at the very in front of the computer is not easy. Sometimes I tend to make error in the calculation. So make sure that you revise positive, negative, and so on. Okay.
Okay, sir.
All right. Okay. So that's end of our discussion today. Bye bye.
Thank you, sir.
Bye bye. Bye bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye bye. Bye bye.
Thank you,
Bye
sir.
bye. Bye bye. Bye bye.
Thank you, sir.